I'm going to talk a little bit today about some of the work that I've been doing in my PhD project, which is all about annual sow thistle, aka milk thistle, and prickly lettuce, and particularly some of the management issues that come up in lentils. And some of those issues are, we've got herbicide resistance in these species. There are very few control options in lentils. And both species produce large amounts of highly mobile, wind-dispersed seed. So we've got mobile resistance genes, therefore. So we've been doing quite a bit of screening of populations of annual sow thistle. We've got data going back about a decade across the whole southern region, screening for resistance. And what we've found is the SU resistance to the group B SUs is really high. In the mid-north and the York Peninsula, we're looking at about 90% of populations coming up resistant to the SUs, and that is a little bit higher than the overall southern cropping region average. But for the IMI herbicides, we're not seeing quite that high frequency of resistance yet. It's sort of around the 70 to 80. We're actually seeing also lower percent survival in those populations. So fewer populations resistant, but also they're not as resistant to the IMIs as they are to the SUs. What we're seeing in prickly lettuce is a bit different. So we've only got 1 year of screening, survey screening data recently for this, but we're seeing 100% of those populations come up as resistant to both the IMIs and the SUs, which is different from previous surveys done, about 10 years ago on prickly lettuce. We weren't seeing quite those numbers yet. And we're also seeing the percent survival, so the level of resistance to the IMIs, about on par with the SUs in prickly lettuce as well. So a bit of a different story between the two weeds. Another thing I've been doing in my project is a management trial to try to exploit the fact that these weeds are a lot easier to manage in cereals than they are in lentils. So can that provide a benefit to the lentil phase of rotation? So I did a 2-year trial at a couple of different sites, and I applied treatments to the wheat phase and then assessed carryover benefit in the lentil phase or in the crop phase following. So I used a couple of post-emergent herbicide treatments. I had a conventional treatment which basically involved MCPA and Ally, knowing that both the prickly lettuce and sow thistle populations at the site were group B resistant, and a proactive treatment which was Flight, so a CFI mix. And I ended up finding that the carryover effect was significant just for sow thistle at one of the sites, which had the highest initial density. So I did see a benefit there. And interestingly, the conventional treatment performed better than the untreated in the first year, so in the wheat. So it seemed to be working. But by the second year, at the beginning of the second year, there was no longer any difference. And that could be potentially because the populations of those weeds at the site were resistant to the residual component of that conventional treatments. It can appear to be working in the first year, but by the time we got to the next year, that benefit was no longer apparent. So benefit for high densities of sow thistle, but we also saw in some cases the density of weeds actually increase from the first year to the next year, including in one case we had eliminated prickly lettuce from the trial area in the first year, but it was there in the second year. So that's an indication that that's coming in from outside of the trial area, and always something to keep in mind with these wind-dispersed weeds, especially where they are able to take hold and grow under reduced competition. They'll produce huge amounts of seed. So if you've got high density, it is worth going hard in wheat to provide a benefit the next year for your lentil crop, but also keep in mind to keep an eye out for any weeds that might be germinating in seeding misses or on your fence lines. So if you've got bare fence lines, make sure they stay bare. You might not have control over what happens on the roadsides, but just keep an eye out and be mindful if you've got a significant population there. Just be mindful of where that seed could potentially be ending up. Another part of my project has been looking at some of the molecular basis for resistance, and I've been using this work to understand the diversity of resistance mutations that are out there causing the SU and the IMI resistance, and also to try to understand how dispersal is happening in these species. So I've sampled populations from across the mid-north and York Peninsula, and I've also intensively sampled a grower paddock, a single paddock. And I ended up finding a lot of different mutations. We know from the literature that most mutations of this type cause SU resistance, but IMI resistance is a bit hit and miss and actually can depend on the species. So for prickly lettuce, across the entire landscape, Mid-North and York Peninsula, I found 5 different resistance mutations. In the paddock, I also found all 5 of these mutations. And looking at the genetic diversity and population structure in these individuals, I saw quite a bit of clustering. So that means that mainly with prickly lettuce, we're seeing local dispersal with the occasional long distance event. For annual sow thistle, I found 6 different mutations across the landscape, and again, all 6 were found in that paddock, and I saw no evidence of genetic clustering. So this means that these species are dispersing quite freely at shorter and longer scales. And interestingly, the range of diversity that I saw across the Mid-North and the York Peninsula was about the same as the range of genetic diversity represented in just that single paddock. So this means that there are a lot of resistance mutations out there, a diversity of mutations, even on a small spatial scale, and that could mean that IMI resistance is present in the landscape already. It likely is, and continued use of these herbicides will obviously select for it. And also the species are highly dispersive, in particular sow thistle. So just going back to some take-home messages, we are seeing really high levels of SU resistance, but IMI resistance in annual sow thistle is lagging slightly behind SU resistance, whereas it isn't for prickly lettuce. And future work is going to be trying to understand what all of these different mutations mean for both of these species, and also examining whether the fact that annual sow thistle, it actually has 2 genomes, therefore 2 copies of the ALS gene. So it can have either both copies mutated or only 1 copy. And we're going to try to look at whether that might be one of the things that's causing this lag in the IMI resistance in sow thistle when compared to prickly lettuce. If you're dealing with really high densities, going hard in wheat and keeping in mind that the group B chemistry is probably not very strong on these species, but also keeping an eye out for invasion from outside the paddock and keeping in mind that these species are highly dispersive. So keep an eye out for resistance and migration of resistance genes. It really depends on whether they are on the soil surface or if they get buried. Really, germination is mainly dependent on available moisture. So if they're on the soil surface and moisture is available, most of them will germinate. But if they get buried and they don't have the light response, they can last a bit longer. We've got seed collected from the last survey of the Mid-North in 2013, and that still germinates this year. That's been kept obviously in storage conditions. So it can persist if it hasn't got those germination cues, but generally most of it is short-lived. But yeah, there is definitely the possibility, and I did a little bit of work comparing the light response of populations from different regions, and seeing a little bit of variability in light response across different cropping regions in South Australia between populations. So there is definitely potential for some of these to come up from depth, but mainly if they're covered, that seed will persist a bit longer. Yeah, so the resistance situation in South Australia definitely dominated by the group Bs. There is resistance identified to the group I herbicides from southeastern South Australia. That's really still quite rare, but it is there. It's low level, so not quite a strong resistance, but it is definitely there. And glyphosate resistance is known in Northern Australia, so Queensland and New South Wales. So definitely something to keep in mind and keep an eye out for, but it's not, neither case is known in this region of South Australia. I think it's worth keeping in mind that 2,4-D on a larger sow thistle probably isn't going to have the activity you might like, but in general, the group Is are a lower risk of resistance than Group B's, of course, but the risk is definitely still there. As we see in the southeast, it's starting to, initially it was a grower submitted sample, but it has been picked up now in the random surveys as well, the most recent round that went through that area.
To start with, I would like to thank GRDC for funding my beautiful project on management of broadleaf weeds and grass weeds in pulse-based rotations. And I'm also blessed with a wonderful team of consultants, growers, Hartfield side, and my colleagues. They help me day in and day out to make my job easier while dealing with some of the hard weeds in our systems. To start with, I would like to share my research experiences regarding broadleaf management in our high intensity break crop systems and the use of IMI technology for tackling those broadleaf weeds. As we all know that we have now multiple crop options available, both cereal and break crop phase, where we can use IMI herbicides. However, the excessive use of IMI herbicides carries the risk of development of resistance in broadleaf weeds. As we have already seen that reports of broadleaf weeds like wild turnip, Indian hedge mustard, saw thistles have developed resistance to IMIs in our systems in South Australia. So we get a lot of concerns from the growers where they say that they would like to rather grow a non-IMI cultivar, but they feel locked into the system because of the persistence of IMI residues, especially when we see the last 3 years when the rainfall is below normal, so when there is more chance of persistence of those IMI herbicides. So in the last 2 years, we were looking into the approaches or strategies which we can adopt so that we can judiciously use those IMI herbicides in our high break intensity crop rotations. We had a couple of trials, one at Hart and one at Butte, and the focus was Bifora, vetch and bed straw management, and the crop rotations were canola, lentil, canola, wheat and barley at Hart, and lentil wheat at Butte. And we wanted to see whether there is a better, which is a better way of using herbicides, if we use it in the break crop phase and relying on their residues in the cereal crop phase, or vice versa, or is there any additional benefits of using IMI herbicides consecutively in 2 years in both break crop phase and followed by in the cereal phase. And we saw in the first year in 2018 in case of canola and in lentils, we found that use of IMIs were essential for controlling bed straw, vetch and Bifora in break crops. However, in cereals, we could easily control those broadleaf weeds with groups G and I herbicide options were in the cereal crop phase. So there was clearly we could save IMI herbicides in the cereal crop phase. And in the second year, we found that use of IMI herbicides in the break crop phase and avoiding in the following cereal crop phase was the best strategy, where we could rely on residues of IMIs in cereal crop phase, especially when the crop season rainfall was below 150 mils of rainfall in the first year. So further we saw that when we use IMI herbicides again in the cereal phase, after we have used in the preceding break crop phase, there was no additional benefit of control was noticed for controlling broadleaf weeds in cereal crop phase. So to summarize this, that we found the best strategy of using IMI herbicides is to use them in the break crop phase and rely on their residues in the succeeding cereal crop phase, where we have more options from diverse group of chemistry, from group Gs, group Is, where we can tackle those broadleaf weeds in a better way. The next thing which I want to share is managing ryegrass in lentils. Over the years, we know that group A herbicide clethodim has been our main strength of controlling ryegrass in break crop phase. Excessive adoption of break crops in the last 1 decade or so, we have overused that chemistry and has resulted in widespread resistance buildup in ryegrass for group A dim chemistry herbicides. What that has done is that has done more pressure on alternate pre-emergent herbicides from group J's and K's like Boxer Gold and Secura. And in this project, we had done a survey on the paddocks which had high intensity break crop rotations, like they had at least 2 times of either canola or lentils grown and in the last 5 years. And herbicide resistant screening results, they revealed that about 25% of the ryegrass populations had started developing resistance to Boxer Gold and Secura. When I looked back into the history of the herbicide use in those paddocks, and I found that those herbicides were quite commonly used up to 4 times in the last 5 years. So that sort of herbicide, like excessive use of group J's and K's, especially in high intensity break crop systems, is definitely raising the concerns for the sustainability of group J and K herbicides, which are really important for both cereal and and pulses. So this trial we are working for the last 4 years. This is the 4-year trial where we are looking for the options, what options we have got when it comes to sustain group J's and K's. So we have seen like propyzamide, group D herbicides, it's showing really good control of those group J and K resistant ryegrass populations. Another herbicide which is in the pipeline, that is Ultro, that is a new mode of action, group E herbicide. It is also showing equally effective for controlling group J and K resistant ryegrass populations. So the thing is, we are getting more options in cereal phase as well. But the key would be how we are using those herbicides, how we are rotating those herbicides into our systems, because that will be the real key to sustain all these pre-emergent herbicides for a long period of time. So thing is, like, we have to adopt a holistic approach right from the sowing till harvest. So how we can control those ryegrass population earlier in the season by rotating our mode of action, and how we can reduce their seed set by adopting strategies like harvest seed, weed seed control measures later in the season, which will reduce the weed inoculum for the next season. We have a big challenge for us in terms of sustaining our diverse options of pre-emergent chemistries. That will be our lifeline for controlling ryegrass in our systems, and how we play the correct shots, like selection of correct herbicide strategies, and play within the rules, like following product labels to the true spirit. That will be the biggest challenge to sustain these chemistries in our systems. Thank you.